some physics students. What are vectors? These are physical quantities that have both magnitude and direction. They are physical quantities that have what? Both magnitude and what? Direction. Magnitude and direction. So if you are talking about magnitude, you are talking about size. Now, what do you mean by this magnitude or size? How small or how big a physical quantity is what we call what? Magnitude. For instance, look at this marker. What is the size of this marker? That is when you put it on a weighing machine, you weigh it, you know the size. So as it is now, does this marker, does it have a direction? The answer is what? No. Because you can't say this is direction because this is the air, this is the direction because no, it does not really have a direction. So we call this marker a scalar quantity. Why? Because it does not have what? Direction. So any quantity that has both size and direction, or you can get the size or the magnitude as well as the direction, is what we call what? Vectors in physics. Now, what is this direction we are talking about? The direction we are talking about is the polar coordinate. Is that we are talking about the north, or we are talking about what? The south. We are talking about the what? The west. We are talking about the what? The east. For instance, to make it clarity, if you are talking about the movement of vehicles, if you are talking about human movement, our movement is based on what? Scalar, because we do not have what? Direction. If I'm moving from here to there, I can go in any direction. Because no direction, you can only know the distance I am making, which is the size. You can't take the direction, so it is what? Scalar. But if you are talking about direction, it is what? Vector. And what is that quantity that can give us what? Vector, which is what? The movement of an airplane. Any aircraft goes with what? Vector. That is when they will tell you that the plane is moving, is going from Nigeria to US on, let's say, 30,000 kilometers. In what direction? In the direction of what? 60 degrees northeast. So this is the direction. This is the size of the distance it's going to cover. And this is the direction in which the plane or the aircraft will be moving. So we say the whole stuff is what? Vector. So that is what we'll be dealing with today. So I believe you are following me. Okay, what are we discussing about vector? That's the simple definition of what? Vectors. They are physical quantities that have both magnitude and direction. If we say physical means what you can see, what you can touch. So they are physical quantities, what we can see. You can see the way they are going, you can see how big they are. That's the word physical quantities. Now, what are the things we'll be discussing about vectors? We've talked about the definition. Now, what are the quantities that are vector in nature? So that's what example of what? Of vectors. In physics, the least example of vector is what? We talk about what? Displacement. Displacement is the movement of an object in a specified direction. Movement of an object in a particular direction. Another one, we have velocity. Velocity is what? Rate of change of displacement with time. Another one we have what? Acceleration. Another one we have what? Force. Another one we have what? Momentum. We have what? Impulse. We have what? Pressure, and so on and so forth. So we have various vector quantities. Now, before I forget, students, please take note. Work, energy, and power, they are all scalar quantities. Work is a scalar quantity, energy is a scalar quantity, power is a scalar quantity. Please don't forget. So many people argue that work is a what? Vector quantity, but it is not. Now, before I go to resolution of vectors, let me quickly clear this. How can you differentiate scalar quantity and vector quantity in exam? For instance, this is my own method. It works for everything except for some special cases like this. For instance, now, What is velocity a scalar quantity or a vector quantity? Look at it. Write the formula of velocity. What's the unit? What's the formula? Velocity was displacement over what? Time. Displacement is what? Vector. Time is what? Scalar. So far, one of the quantity in the formula is vector. It makes the whole quantity to be what? Vector. Another example, acceleration. Acceleration is what? Velocity over what? Time. What is velocity? Vector. What is time? Scalar. So it makes the whole acceleration to be what? Vector. Because one of the quantity is what? Vector. Another one, let's go to impulse. Impulse is what? Force over force times what? Time. What is force? Vector. What is time? Scalar. So it makes, because one of this is vector, it makes impulse to be what? Vector. Another one is momentum. Momentum is what? Mass times what? Velocity. Velocity is what? Vector. Mass is what? Scalar. So it makes momentum to be what? Vector. But it does not work enough. Okay, let's see pressure. Pressure is what? Force over what? Area. Force is what? Vector. Area is what? Scalar. So it makes pressure to be what? Vector. But not in the case of what? Work. Because work is what? Force times distance. Force is what? Vector. Distance is what? Scalar. So you are supposed to have what? Work as what? Vector. But work is what? Scalar. So this is one of the exceptions. So students, when you see this in the exam, how do you separate or how do you differentiate vectors from scalar? Just bring out this your method and it works. So that is by the way. So let's go to, we talked about the definition, we talked about the example. Let's go to resolution of vectors. How do you resolve vectors? This is physics. How do you resolve vectors? Number one, let us talk about, I'm talking about resolution. How do you identify resolution? On paper, vector is represented with what? A letter and a cap or an arrow. So this is a vector, or you see something like this. This is how to represent vector on paper. So we call this representation of what? Vectors. Then how do you know the size of a vector? I'm talking about resolution of vectors. So I'm talking about representation now. The size of a vector. The size of a vector is all about what? How big it is. For instance, 3 Newton and what? 5 Newton. We should all know by this question that what? 5 Newton is bigger than what? 3 Newton. So the longer the arrow, the bigger the size. So this is bigger than this. So we should all know that this is what? 3 Newton and this is what? 5 Newton. Then direction. Wherever the cap of the arrow is going is the direction of the what? Vector. I have something like this. I have something like this. So this is what, if I put my 4 cardinal points here, north, south, west, east. So we say this is going what? This is south, east. And this is what? Let me say north. Or is it, let me tint it a little bit. So this is north, what? East. So that's the direction of what? Of vectors. How to represent a vector on paper. The size of the vector depends on how long the arrow is, and the direction is talking about what? Where the end of the vector is directed towards. That is what? Vector. So let us now resolve vector. How do you resolve vector? So resolution of, I'm talking about resolution of what? 2 vectors. Resolution of 2 vectors. Now, in this case, students make mistake, or students don't seem to understand what we call what? Resolution of vector. Or when they give students questions on vectors, they make mistake easily. Now, if you are talking about resolution of vectors, you are actually talking about the angles or the direction. Don't forget, vectors solely deals with what? Vectors solely deal with what? Direction. Now, we have 3 directions I'm going to talk about here. 3 directions. Now, when 2 vectors are parallel to each other, when two vectors are perpendicular to each other. So parallel here, the angle is what? 0. Perpendicular here, the angle is what? 90. And I can have acute angle or have what? Obtuse angle. When you are able to deal with this in exam, then you are going to do in exam. So let's take the first one. When two vectors are parallel to each other. When two vectors are parallel to each other, what do you mean by that? In mathematics, when two lines are parallel to each other, we say the angle is what? 0. So in physics here, we have two cases of this. So it is either they are going in the same direction or they are going in what? Opposite direction. So this means when they are parallel to each other, it means the angle between them is what? 0. So if I have vector A and vector B, this is longer than this, so this should be bigger than this. They are going in the same direction. So if this is 5 Newton and this is what? 3 Newton. So what is their resultant? The resultant of this vector is what? 8. Why is it 8? Because they are going in the same direction. 5 plus 3 is what? 8 Newton. And this, if this is 3 and if this is 5 and this is 3, they are going in opposite direction and they are parallel to each other. So this is this way, this is this way. Then you subtract smaller from bigger. So the resultant is what? 5 minus 3, which is what? 2 Newton. So that is, we are done with this. It's as simple as that. Now, what is resultant? What is resultant of a vector? The resultant of a vector is what? Is the solution of the two vectors. Then how do you solve resultant of a vector? It now depends on these angles. So the resultant of a vector will still give you the same effect of the two vectors. That's one thing about the resultant. It is the solution to the two vectors which will give you the same effect. So now I've talked about what? When they are parallel to each other. And when they are parallel, the angle between them is what? 0. Don't forget, theta radian angle, and that's the value. So the second one is what? When they are perpendicular to each other. When two vectors are perpendicular to each other. How do you solve that? When they are perpendicular, we say the angle is what? 90 degrees. So in mathematics, perpendicularity means what? 90. Or we say what? Complementary. When the sum of two angles is complementary, so we say the angle is what? 90 degrees. That is by the way. So if I have vector 1, vector 2, this is 3, this is 4 Newton, and this is what? 3 Newton. What is the resultant of these two vectors? Look at it. The angle between them is what? 90. This is one vector, this is another vector. The angle between them is what? 90. Now for this particular case, perpendicularity, when the angle between two vectors is 90, the resultant is being solved by Pythagoras theorem. The resultant will give you Pythagoras theorem, which is what? Which is the leg of the what? Hypotenuse. So the resultant of this is just what? Do like this. So this is the hypotenuse, which is what? This is 4, 3, and by your Pythagorean triple, this will be what? 5. So the resultant of this vector is what? 5 Newton. Now, don't forget that we are dealing with vectors. Vectors is dealing with what? Magnitude and what? Direction. So the magnitude of the resultant of these two vectors is what? 5 Newton. What is the direction? We are dealing with vectors. Vectors deal with the two. Now, the direction of the vector is the angle between the resultant and the horizontal vector. This is my resultant. This is your resultant vector. So this is my what? Angle. So how do I get this angle, which is the direction? So definitely for mathematics, you know that what? Tan, you are using tan alpha straight equals to what? Opposite. Tan is what? Opposite over what? Adjacent. So tan alpha, that's the angle I'm looking. What is opposite? 4. What's adjacent? 3. Then alpha goes to what? Arctan 4 over 3. You can finish that. And that is the angle. So how do we particularly get the angle? Look at this. Okay, let me draw it here. We have this. you have this. So see, draw your, this is my alpha, your north, and your what? South, west, east. So the angle is a bit what? North, west. So whatever you are going to get, for instance, if alpha equals to 40 degrees, so you are going to say it is what? The direction will now be what? North 40 degrees what? West. That is the direction. So this is the direction we are talking about. And the size, the magnitude, how big it is what? So which means the resultant of the two vectors is 5 meters going in this direction. So case 2 solved. So resolution of vectors can be in 3 cases. Case 1, case 2, case 3. So we are going to case 3 now. Case 3 is when the angle is what? Either acute or obtuse. How do you solve? Recall, when the angle is 0 or they are parallel to each other, you subtract or you add. You add when they are going in the same direction. You subtract when they are going in what? Opposite direction. When the angle between them is 90 degrees, how do you solve them? You solve it using what? Pythagoras theorem. Pythagoras theorem. That's how to solve it. Then you calculate your what? Angle. How do you calculate your angle? The angle is what? The angle between what? The resultant and the horizontal vector. So that is that. So the last one is what? Acute. When the angle between the two vectors is what? Acute or obtuse. What are acute angles mathematically? Acute angles are angles between 0 and what? 90. Between 0 and what? 90. These are acute angles. And what are the examples of acute angles? Special angles, so to say, I have 30, I have 45, I have 60. These are what? Acute angles. What are obtuse angles? Obtuse angles are angles between what? 90 and less than what? 180 degrees. So what are these special angles? Example of obtuse angles are what? I can have 145, 130, 150, and so on and so forth. So this is the definition of what? Acute angles. Definition of what? Obtuse angles. Now, when two vectors are subtended by either of this or this, how do you solve it? You solve it using what? Parallelogram law of vectors, which boils down to what? Cosine rule. So what do you mean by that? I have vector A, I have vector B. This angle was, for instance, 60. 60 is not 0, it's not 90, it's 60. So we can't use this method, we can't use this method. So this, for this, we use what? Parallelogram law of vectors, which will eventually give you what? Cosine rule. Then we need to really resolve this. This is key. This resolution is key. We are talking about resolution of two vectors. Now look at this. This is smaller than this. So definitely look at this. This is smaller than this. Definitely the value of this vector will be smaller than this. So let me say this 3 Newton and this is what? 8 Newton. Don't forget the magnitude of a vector depends on how long the arrow is. So this should be, so don't put this 8 and this 3. It is wrong. So now, how do we find the resultant? We are asked to find the resultant here. Can we get that? We can't use parallel and we can't use perpendicular. So we need to resolve these two vectors to what? Parallelogram of vector using this, and it boils down to this. So we need to do 2 in 1. So how do we do this? Solution. I want to resolve this. Look at it. I have this, I have this. The angle between them is what? 60 degrees. This is what? 3 Newton. This is what? 8 Newton. Now, parallelogram law of vector, which means I can transform this to parallelogram. Now, what is one of the properties of the parallelogram? One of the properties is that two opposite sides are parallel and equal. So look at this now. So let me make this parallel. This side is parallel. This is parallel to this. So as this is 3, this is also what? 3. Then again, this is also parallel to this. As this is 8, this is also what? 8. So if this is 60, let me extend this. This also will be what? 60. So at this place will be what? Angle on the straight line is what? 180. 180 minus 60, this will be what? 120 degrees. And this will be my what? Resultant. So the new diagram is what? This, this. So this is what? 120. Don't forget, I still have my two vector 8 and what? 3. The angle between them now is now what? 120. This is my resultant. So I have used parallelogram law of vector now to resolve this. I have resolved this now. Then bring it back. So don't forget, we are given 60, but it has been transformed to what? 120. So another way to reason this is that the base angle of a parallelogram sum up to what? The sum of base angles is what? 180. So whatever you are given, just transform it to what? 120. You transform it without using that. So how do we get this resultant? You now use what? Cosine rule. What is cosine rule? Two sides are given with one angle to get the third side. So cosine rule says that what? R squared equals to what? 8 squared plus what? 3 squared minus 2 times 8 times 3. Cosine what? 120 degrees. So in exam, if your exam is objective, you don't need to resolve before you solve. This cos what? Just do cosine 180 minus what? What you are given? 60, which will give you what? 120. So whatever you are given, just subtract it from 180 to get the actual value. Then you solve. You do what? You solve. So that will give us so 8 squared is what? 64 plus 9 minus 16 times 3. That's 24 times 3, that's 48. Cos 120 is what? That's cos 60 half. Negative, that's minus half. Cos 120 is minus half. Let's confirm that. Cos 120. Yes, correct. So 64 plus 9. 64 plus 9. That gives us 73. Plus and minus that minus plus 40 divided by 224. So this is what? 77, 97. So the R square is this. Then R equals to square root of 97, which is what? Square root of 97, which will give us what? 9.85 meters. Now this is how big the resultant force is. So what is the direction? This is the magnitude. What is the direction? Don't forget we are dealing with what? Vectors. Magnitude and direction. So how can I get my direction? Then don't forget I said the direction is the angle between the resultant and the horizontal force. The angle between the resultant, this is the horizontal force, so this is my direction. That's my angle. So how can I get the angle? So once I have gotten the magnitude, how do I get the direction? So my R is what? 9.85. Then we now use, to get our angle, use what we call what? Sine rule. We call what? Sine rule. How do I get sine rule? When 2 or 3 sides are given, I want to get the angle. Then look at this. Sine rule says that what? If I have a triangle A, B, C, the side facing is small c, small a, small b. Sine rule states that A over sine A equals what? B over sine B equals what? C over sine C. So I want to relate that side over sine of angle. So I want to relate that to what we have here. So side facing angle, side facing angle, side facing angle. So I'm going to do that here. Side facing this angle. So that's what? 3 over sine alpha equals to what? Side facing this angle. 9.85 over sine what? 120. This side facing this angle. This side facing this angle. This side is facing this angle, but we don't know this angle. We can't use that. So we are using 2 out of the 3. So how do we get sine alpha? So we have a sine alpha plus multiply equals to what? 3 sine 120 divided by what? 9.85. So that's what? 3 sine 120. That's what? 2.60 over 9.85 divided by 9.85. That's what? 0.26. So sine alpha. So if sine alpha is what is alpha? Alpha equals what? Arcsine of this. So that's what? Arcsine of the answer. Arcsine of answer is what? 15.29 degrees. So the direction is what? 15.29 degrees. And to get a coordinate, we put it here. So this is northeast. So it's going to give us what? It's going to give us approximately 15 degrees north degree east. Thank you for watching. You can begin to pause the video one after the other so as to get it explicitly. Thanks for watching. God bless you. Please watch, like, comment, and subscribe to our channel. Thank you. God bless you. I remain Mr. Ola. Thank you.